Okay, hi everyone. Javent Lienata here. Today I will talk about a Jetpack library called Jetpack Benchmark. So what is this? It is basically a Jetpack component which will help you benchmark your Android app. Let's move on and then we'll have prerequisites. So before we jump into the library, I hope that you already know how to operate with Git. You know how to develop an Android app, of course, using the Android Studio and Kotlin. And you know how to build multi-module app on Android. And of course, you need to know how to write an instrumentation test on Android Studio. Why? Because this Jetpack Benchmark library is based on instrumentation tests. And our agenda today will be introduction. So what is a benchmark and why do we need to benchmark? And we'll try to benchmark some Kotlin code using measure time list and measure nano time. And then we'll jump into the library itself. We'll have a quick start, project setup, and an example here. We'll try to compare between linear layout, relative layout, and constant layout on a flat hierarchy. And then we'll talk about some additional configuration on the library, and we'll try to run the library on CI. So let's move on. Okay, so what is benchmark here? If you try to copy and paste it into Google Translate, it will say that it's evaluate or check something by comparison with the standard. So the key point here is comparison. When you want to benchmark something, you need to compare between more than one things, right? So if you don't have a comparison, you only evaluate one things, I think that's not called a benchmark. You can just say it, maybe stress test. And then, yeah, so why do we need to benchmark here? So Donald Knuth ever said that 97% of the time we do this parameter optimization, which is the root of all evil. Why? Because when we are doing optimization, sometimes, maybe most of the time, not every time, right? We have a negative impact on our debugging and maintenance ability. Well, uh, me myself prefer to call it the comparison between UX versus DX. So where UX is our user experience, which means our apps is quite optimized for the user side. Meanwhile, DX means developer experience, which our app is quite maintainable. So let's say, for example, Java versus Kotlin, right? Uh, Most of you maybe have ever compared between those two languages. You have decide whether to move to Kotlin or not. I think when you're deciding it, you will have a comparison between these two. So when you move to Kotlin, we can say that we will have a better developer experience. Why? Because Kotlin is more idiomatic. It's easier to code in Kotlin, but still you will try to benchmark it, right? You'll compare the user experience. Will it have a negative impact or noticeable impact when you are moving from Java to Kotlin? Will it still be optimized? So yeah, that's why you need to benchmark before deciding to move into Kotlin. Okay, let's have an example here. So we have three examples here. For the first one, we'll try to benchmark for each, which we will iterate the list using for each, and we will try to access the element inside it. And then the second one, we have a for size, which we will iterate the list using a for I in 0 until the size of the list, and then we will try to access the index using I. And the third one, we have the for I, which we will iterate the list using the for I, and then we will try to access the element inside using I. And we'll see the time needed to run these three codes. So the implementation here is we create a list, empty list first, and then we have a function called prepare, which will clear all the lists, and then do a garage collection here. Why do I do a garage collection here? Because I want to make sure before jumping into each benchmark, we have a clear memory, and we don't want to catch the result from the benchmark before. And then after clearing the memory, we will try to populate the data by adding the 0 until 1 million into the mutable list here. And then we'll try to benchmark it for 9 times for each, for size, and for I. We'll do it each 9 times, and we'll have the result. Oh, by the way, if you want to see the code, you can try to scan this QR code, and you will have the GitHub gist for this code here. Okay, so we have the comparison between these three approach for iteration, right? The first one is for each, which will take this long. The second one is for size, which will take this long. And the third one is for I. So as we can see here, for size is a bit more optimized, I think, a bit faster than for each and for I. It's a bit faster, but is it necessary to change all our code from for each and for I into for size? So let's jump back into the code here. If we see for size here, the code is a little longer, right, than the for each one. And you can see that for each is more idiom, because we know that when we are calling a list and for each, we iterate each of the list inside element inside the list here. But using for I, it will be more not idiom. It will be less idiom. And then you can decide whether you want to sacrifice the idiomatic for this little performance increase. Okay, so to make it clear, let's see the second example. We have the benchmark non-inline and the benchmark inline here. So what will it do? The first is the benchmark non-inline. It will measure the nano time that needs to run this non-inline function. Let's see the function first. So the non-inline function will take time as the first parameter and the block of lambda into the second parameter. The function will do iteration for e until time and run the block code from the second parameters. So for this function, it will run the a plus equal 1 for 1 trillion times on a non-inline function. Let's compare to the second one. We have the benchmark inline here. It's pretty much the same with the first one, but the difference is we add this inline modifier in the function as a prefix. So we'll try to benchmark these two, and let's see which one is better. Okay, so like before, I will do a grab collection before adding it to the benchmark. Then I will try to run it 9 times. And let's see the answer. Okay, so we can see here inline function is a lot faster than non-inline, right? So you can see the performance difference here after doing the benchmark. And then we can compare the developer experience here. So the effort to get this performance gain is you need to only add the inline modifier on all function that can be inline, right? So still the decision is yours. If you want to decide the approach, whether you want to change all inline function using the inline modifier or no, it's still yours to decide. But we can see the performance impact is a lot and the effort to do it is not that much. So to answer this, so why do we need benchmark? So when we do benchmark, we can determine whether the result of our optimization worth the cost of the maintainability. So this is why do we need to do it. And then let's see how to benchmark our Kotlin code. So to benchmark Kotlin code, usually we can use this function, which is a measure time release. We'll receive a block of lambda as the first parameter, and it will execute it and returns the time needed to do it in milliseconds. Let's say we have these two functions here, and we want to benchmark and know which one is better or more optimized. So it's like the function before. We only change the prefix inline here. So we'll compare it, the inline repeat versus no inline repeat. So basically how we do it, you can just call the function here, and then you wrap it into measure time release. So you wrap everything that you want to benchmark using measure time release here, and you print it. So after you print it, it will output the result, the time needed to run the function here. So for example, we want 1 trillion times of a plus equal 1 will take 48 time millis. And then this no inline repeat b plus equal 1 for 1 trillion times will take 1207 time millis. So a little tips here, we can create the helper or utils function so we can easily log everything using the time millis. So you can just make a function, let's call it log measure time millis, and it will receive the description as the first parameter, and the second one will be the block that we want to measure. So we store it into the time list, the result, and then we call the log function. Okay, so for example, we want to log the onCreate block on our activity, or maybe other components. We can just wrap everything inside the log measure time list, and then you add the description here. And then when it runs, it will output the log into the logcat. So it will be something like this. Log measure time list onCreate took how many milliseconds. But how do we handle warm up and measure repeated benchmark on Android code without changing the implementation code? For example, most of the time when we do benchmark, we don't run only one time, right? When we do benchmark, we want to run it repeated, like what I do before here. So here I repeat the benchmark for 9 times to get a better result, so I can compare. So yeah, how we do it without changing the implementation code, it's impossible for us to run the code multiple times in production, right? It will have a bad experience for the user. So how do we do it? Here comes the Jetpack Benchmark, a library from Google itself. So let's have a quick start here. So Jetpack Benchmark, what is it? It's a library that measures the performance of your Android app code, and it helps us reduce measurement error because it helps us handling the warm up and the CPU clocks and etc. If you want to dive deep into it, and it is integrated into Android Studio, and it runs on JUnit instrumentation tests. So when you already have the instrumentation test on your app, you can just add this benchmark library to run the benchmark. And good news is, yeah, it's already version 1 last year. So this year I think it already have 1.1, but it's still on RC or alpha. I haven't checked it. Okay, so quick start here. How to have the library inside our app? Simply just add the library into your modules build Gradle like this, and add it on the Android test flavor, so it doesn't goes into production. And then you set the JVM target to 1.8 if you haven't, because the benchmark will need to run on JVM target 1.8. And then we have these important things that we must note. Um, on the benchmark module, or when we are doing benchmark, it's important to disable the debugging temporarily. For example, here on our Android manifest application, you set the debuggable into false, and then you ignore the hardcode debug mode. So you replace the debuggable using the manifest. So why do we need to do this? Because when we are benchmarking our app, we want to benchmark the performance on the user side, right? We are not benchmarking the performance on the developer side. We don't want all the debug ability or like the breakpoints or logger or something mess up with our benchmark result. That's why we need to force all the debuggable into false here. But the problem is, oh, let's jump into this first. Okay, so quick start. How do we add our benchmark on our code? So basically, you just need to add this rule, add get rule, and we store it into the benchmark rule here. Like when you are doing activity test, you using activity rule, we can use the benchmark rule too. And then for everything that you want to measure or benchmark, you just call the benchmark rule dot measure repeated, and you call the function you want to benchmark. So basically, when you run the test, it will output how long it takes to call this do some work method. But we have a problem here. One does not simply do benchmark on production module, right? You don't want to put this debuggable false on your production module or your app, because when you put it false, then every developers won't be able to debug the app, right? So that's why we try to set up a project so we can use Jetpack Benchmark easily and better. So when we set up our Jetpack Benchmark project, it's better if we create a new module for benchmark. So it's better if you don't use the currently app module. Because why? Because we need to force the application debuggable to false. If you create a new module, we can have a separate configuration for the app. So the point is we want to isolate the custom configuration only on the benchmark module. And we need to separate our features that we want to benchmark from our app. Why? Because our benchmark module will need to depend on the feature module here. And if it is on the app module or base module, our benchmark module won't be able to depend on it, and we can't test it. So let's say we already have this kind of structure here. So we have a feature module, and then we have a feature example on our feature module, and then we have our app module here, and all our features are not inside app modules anymore. It's spread into a smaller module outside it. And then we can create a new benchmark module. It's available on the Android Studio 3.6, and it will be look like this. When you next, and then you create it. Now we have three modules. We have the app modules, we have the benchmark modules, and we have the feature modules. So on our benchmark module here on the build Gradle, we need to put this code here, the test instrumentation runner argument, and we change the Android X benchmark suppress errors here. We add the emulator, low battery, unlock, and engineer's build. So why we need to do this? Because if we don't do this, every time we run the test on emulator or low battery or on unlock or engineer's build device, it will raise an error and the test will all fail. So we need to suppress the errors. So all these errors change into warnings. And then, for example, we want to benchmark our feature example. We need to add the dependency on our benchmark module. This is why I said that before we need to extract our features outside our app modules, because the benchmark module needs to depend on every features that it need to be tested. Okay, let's jump to the examples here. Let's say we want to benchmark the time needed to inflate this 3XML layout. We have the empty relative layout, we have the empty constant layout, and we have the empty linear layout. And we have main activity on the feature example, which will only call on create here and set the content view of the activity. And then we have the benchmark mode test on our benchmark module. Add the test into the Android test package. And then, yeah, we can call it layout inflate benchmark here. And yeah, just like usual, you run it on the Android unit 4. So this one is the activity rule. You need to call it because you want to inflate the XML into activity. And then we get the benchmark rule here. And then for the first test, we are testing the constant layout here. We run it on the UI thread test, so it won't be parallel. And then on the render constant layout, we will call the activity rule and get the activity here. And then inside the activity, we want to test or measure how long it takes to set content using the XML that we have. The first one is constant layout, the second one is linear layout, and the third one is relative layout. So we call the set content view and wrap it into measure repeated. So what will happen when you run the code here? It will open the emulator or it will run on the test on your device. And then the difference is you'll get this result when you're running the test. So it will raise some warning because we are using emulator, engineer's build, and CPU clocks. It will say to us that the test may be not valid because we are using this environment. And then we'll have the result here. So when we are calling the render constant layout, it will run 41,000 nanosecond. And when we are calling the linear layout, it will run this long. And then when we are calling the relative layout, it will run this long. So, and the warning above it, we can see that it said that we are running on an emulator. And there is a reason why we don't run on emulator. From the library itself, we'll say the reason. And then we are running on engineer's build, and the library itself will explain to us why. And then we are running on unlock CPU clocks, and the library itself will say a reason why we must not run on unlock CPU clocks and give some solution to it. Okay, if you want to look at another example for this Jetpack benchmark, I think because we are short of time, you can just go into my repository and see I have some example like for constant layout and recycle view and list view and complex layout. You can see it there if you want. And then let's move on to the additional configuration on Jetpack benchmark. So what is good about Jetpack benchmark is you can enable JSON output for your benchmark. So we can use the output itself on our CI. So if you want to enable JSON output, what you need to do is you add this code, the Android.enable additional test output true in your Gradle properties. So when you run the test from terminal, you will have the JSON output as a report. And then you need to add this plugin into your benchmark module. So basically this plugin will have the JSON output process and the file will be outputted on your Android device. If you don't add this plugin, when you run the test on terminal, the output will not show. And then how to get the JSON output here? Okay, so when you just need only to run the test from the Gradle terminal. For example, we call the Gradle W module name connected check for instrumentation test. And then for our example, because we are running it on benchmark module, we can just call this on terminal. And then the result will be generated here. And if you look at the terminal, when you call the .gradle W benchmark connected check, when the test is done, it will have the reports files generated here. And you can get the JSON and it will look something like this. So it will give you some context about where the test is running, at what device, and then what's the model of the device, and then what version of SDK it's using. And we can look at the CPU core, and we can look if the CPU is locked or not. And then we can see the memory bytes here, and we can have the data about if the sustained performance mode is enabled or not. And then all the benchmark will be here. It will be stored in an array with a name, params, and it will say what is the class name here. So you can use it on your CI to have reports. And then you can see how long does it take to run. And then we have the metrics here. So here's the important things. We have the metrics here. The metrics will show us what is the minimum times taken to run the test, and then what's the maximum time, and then the median. And then it will have this array of runs. So we can see that the test is run multiple times. And we can get the result from here. So, and for clock stability, still remember that when we are running the test is giving us a warning about clock unlock clocks, right? CPU clocks. So why? Because the clock's speed on mobile device can change from high state to low state. When we are calling a resource consuming or CPU consuming task, it will go into high state for performance. But when the device gets hot, it will go into low state. And these varying clocks can mess our benchmark. So why this library, this Jetpack Benchmark library, give us the option to lock the clocks at our device, but it will need root access here. I think this root access here is still not supported at Firebase Test Lab. I don't know. But if you are using emulator, you can root your device. So when you're rooting your device on emulator, and then you can call this code .gradle.w lock clocks, and the library itself will try to lock CPU on your device. And note here, every time you reboot your device, it will be unlocked again. And then this library also give you configuration errors like before. When you are not running on debuggable faults, or when you are not running on physical device, for example, you are using emulator, or when you are running with CPU's lock when the device is root, and when you don't have enough battery on your device, it will raise an error. So that's why I need to set the test instrumentation argument to suppress all these errors when it happens, so the test not failing. It's up to you though. If you want to use the physical device, you can just turn off these suppress errors, and you can maybe, if you want to use the physical device, you can just turn on the CPU lock or battery level on your test. And then, okay, so here's the running it on CI part. So for example, we want to run our benchmark on CI. What do we need to do? Okay, here I'm giving example using Zero CI. Okay, I'm not promoted by Zero CI, or I'm not promoting Zero CI. So why do I use this? Because it's free. Yeah, it's free for open source, and it doesn't have any limit on how many minutes I can run in a month for open source project. That's why I use Zero CI. So yep. And then how to install Zero CI on your GitHub? It's quite straightforward though. You can just open the quick start guide here, and then you follow all the steps here. I think you just need to open your GitHub Marketplace and then set your plan, set it to public repositories so it's free. And then you can choose which repository you want to have Zero CI installed. Okay, so let's see the CI script here I'm using for running the benchmark on Cirrus. So the first one is I'm using this container, the reactive circus / Android emulator 28. Yeah, 28. And then why I'm using this tag here? Because when I try to use the image here, the latest image, it's updated into JDK 11. I don't know why. The creator updated into JDK 11, but it's crashed the test. So that's why I try to find out which tag is using the JDK 8. And I think this one is the latest tag that is using JDK 8 there. So and then we set the KVM to true, so we can run on virtualization. And then we set the CPU 8. And then we set the memory for 24 gig. After that, I have a script to download the device here. So I install the system image Android 29 default, and I use the engineer's build here. And then after it's done downloading and installing, I create the device using the FED manager here. I create the device FED force, and then I name the device test. And then I use the ABI default and the x86 and 64 as the architecture. And then I set the param to use system image Android 29 and the ABI here. And I give the min-c arguments is to set the SD card or the external storage here. So I give the external storage 100 megabytes to make sure that it can store the JSON output. And then start the emulator, start the FED, and I'm starting the test device. So because I named the device test here, and then I set it on audio because we don't need audio on CI. And then I set it no window because on CI we don't need any window too. And then set the GPU to use this, and then set it to no snapshot, so we don't have any snapshot or cold hot boot, I think. And then we set it to no audio, no boot animation, and we don't use any camera, so we set it to camera back none, and set it to the system to be routable. And then after starting the emulator, we have a script to wait for the emulator, so it can wait for the emulator before starting the next script here. And then after the emulator is starting, as started, and then we can root the emulator here. After we root the emulator, we will lock the clocks, and then we run the instrumentation test here. So after we finish running the instrumentation test, we can always save the artifacts here. So I save the artifacts into the test, and then I use the path reports here. So everything's inside reports is saved on the artifacts. Why? Because sometimes we want to know if the test is failing, right? When the test fail, we want to know what test is failed, and then we can open the artifact to get the data. And then after that, we save the benchmark result into the artifacts too here. So the part is the outputs connected Android test, and then we give the wildcard here, and we save everything that's JSON. And then one thing to remember here, if you are targeting API 29 and higher, we need to set this flag on our application manifest. Why? Because if you don't set this, the permission to save the JSON will be rejected by the device. So when we set the request legacy external storage to true, the JSON can still be saved on the device by the app. And then voila, the check succeed. And we have the CI running on our GitHub. Yeah, honestly, I've been failing like 40 times before I have this succeed too. And then we can see the result here. So we clone the PR and then download the device and then create it, start it, and wait for it until it's finished. And then we root the device and then lock the CPU. And then we run the instrumentation test. And then we upload both artifacts here. So we can see the result of the JSON is contained here. And then the result of the test can be seen here. So we can use these two to improve our CI. For example, you want to upload your benchmark JSON to your monitors like Grafana, or maybe you want to use Danger to compare like the benchmark on this PR is slower than the PR before or something like that. You can use this to do that. And then I think, yeah, for additional resources, you can learn more about it from the official documentation here. And if you want to learn how to run it on CI, a lot of configuration can be seen here on this link. And if you want to have a step-by-step uh, implementation on benchmarking, I think you can see my orgs blog here. Here, it's quite good. And then if you want to see how Xavier Lorenzo implementing the Jetpack Benchmark on, I think they are using it on the OLX, inside OLX. I think you can see at the droidCon Berlin 2019 here to see how they implement the Jetpack Benchmark on OLX by Xavier Lorenzo. I think, yeah, that's all. Thank you. Okay, so we have a question here. Hypothetical case. If a method is faster when run directly in main thread, but method will have considerable overhead when running in coroutine because of context switching, but can free or relieve the main thread. Which do you consider? Why? I think if you want to answer this question, we need to benchmark it first, right? We don't just hypothetically or assuming the result of the two approach here. I think you can use this Jetpack benchmark, or maybe you can try using the measure time list or on Kotlin playground and do some cases or approach multiple approach and compare the all the result using tables, and then you can get the decision. I can consider one of it though, because I don't have the data yet. I think, yeah, it still need to be benchmarked before we can decide which one we need to consider. Okay, I think hope that answered this question. Yep, for any more question, I think you can contact me at the speakers chat, or I think you can contact me directly later on my email. I think you can see my email at the speaker profile. I will share the slide and the GitHub repositories, and I've done some writings on Medium. I think I will share it all on the speakers blog. Which methods you will prioritize benchmarking? How do you decide when to add a benchmark test? It's quite interesting though. So which methods will you prioritize benchmarking? I think, how about we benchmark everything that we can? Like, I don't think we need to prioritize benchmarking, right? When we have a code that can be benchmarked, you can just log it. And how do you decide when to add a benchmark test? If your instrumentation test it's possibly to add the benchmark rule here there, and it's possibly to do a benchmark on your instrumentation test, it will be good, right? So every time you have a performance impact on your code changes, your CI or your PR will automatically detect it early. And for which methods would you prioritize benchmarking? Based on my experience, I think most of the time, startup app startup is the most important thing. I think I can say it because most users will get into startup when they are opening our app, right? So I think it's best to first benchmark or stress test everything we have on our app startup, so we can see that every changes on our app doesn't slow our app startup, because you don't want the user to have a long time startup, like for like 5 seconds or 6 seconds. It will annoy the users. And if you don't benchmark it, you will notice it. You will notice that our app startup is increasing time to time. Yeah, I think that's my answer for this question. Okay, I think there are no more questions. So thank you for attending. Hope you enjoy the sessions. Bye bye.